In our search throughout the cosmos for alien life, we typically prioritize Earth-like worlds with presumably Earth-like conditions. After all, this is the only sample that we have of life in the universe. The conditions that might make an exoplanet Earth-like include having a mass that's within the range of a few Earth masses so that the gravity is tolerable and not extreme. The planet has to orbit in its star's habitable zone, so it has a temperate climate and potentially liquid water, and ideally, its atmosphere might contain certain chemicals that are biosignatures for life. For example, if we see an exoplanet with a large quantity, like say 25 to 40% of the atmosphere is free molecular oxygen, well, that would be a really remarkable find, and that would be evidence that that planet might host life. Now, unsurprisingly, such Earth-like worlds, worlds that check all of these boxes, are very rare. But there's reason to think that life may not be limited to just these precious few, temperate, humid, Earth-like worlds. Life might exist on a much broader variety of worlds than just your typical Earth-like world. There was an interesting study that was recently published in the journal Nature Astronomy, which explored alternative chemical environments in which life may still be able to survive. I'm going to read the abstract of the study, because it does a really good job summarizing all of the details and the background information of this issue. The authors write, quote, "Theory and observation for the search for life on exoplanets via atmospheric biosignature gases is accelerating, motivated by the capabilities of the next generation of space and ground-based telescopes. The most observationally accessible rocky planet atmospheres are those dominated by molecular hydrogen gas, because the low density of H2 gas leads to an expansive atmosphere." Unquote. Alright, so in this first part, basically what they're saying is that because hydrogen is a small, light particle, it's not very dense. If you have a large amount of it, if you have a lot of them in a container or in a planet's atmosphere, stuck into its gravity well, the hydrogen is not going to compact very densely. And so, large amounts of it in an atmosphere will form a large and puffy atmosphere that extends for many hundreds of kilometers above the planet's surface. Visually, this makes the exoplanet larger. The wider atmosphere will reflect more light, and it makes the planet much easier for astronomers to see. The authors continue, saying, quote, "The capability of life to withstand such exotic environments, however, has not been tested in this context. We demonstrate that single-celled microorganisms, Escherichia coli and yeast, that normally do not inhabit H2-dominated environments can survive and grow in a 100% hydrogen atmosphere. We also describe the astonishing diversity of dozens of different gases produced by E. coli, including many already proposed as potential biosignature gases. For example, nitrous oxide, ammonia, methane thiol, dimethyl sulfide, carbonyl sulfide, and isoprene. This work demonstrates the utility of laboratory experiments to better identify which kinds of alien environments can host some form of possibly detectable life." Unquote. Alright, so this is really exciting, because they've basically shown that simple bacteria and fungi can live and grow while exposed to extreme levels of hydrogen. Such exposure won't kill them, and that's the big takeaway from this research. Their study involved regular sampling of encapsulated cultures that have been exposed to a nutrient solution and various types of atmospheres, including an experimental capsule with a simulated atmosphere that was 100% hydrogen. This regular sampling took place over 80 hours, and it showed a classic growth curve in each microbe population, leveling off as they reached a stable carrying capacity, where the microbial death rate and replication rate were the same. Now there's another cool detail here as well. As the early Earth was very hydrogen-rich and produced life forms that consume hydrogen, such as methanogens and various other extremophiles, it would follow that hydrogen-rich alien planets may be prime locations for life. These hydrogen-rich alien worlds might be very reminiscent of the proto-Earth. Dr. Sarah Seeger is a professor of planetary science, physics, and aeronautics and astronautics at MIT, and she was a lead author of the study. Dr. Seeger said, quote, "There's a diversity of habitable worlds out there, and we have confirmed that Earth-based life can survive in hydrogen-rich atmospheres. We should definitely add these kinds of planets to the menu of options when thinking of life on other worlds, and actually trying to find it." Unquote. When imagining what such a world might be like, Dr. Seeger thinks that it would be different, but not totally unrecognizable from Earth. She said, quote, "We're imagining if you drill down into the surface, it would probably have hydrogen-rich minerals, rather than what we call oxidized ones, and also oceans, as we think all life needs liquid of some kind, and you could probably still see a blue sky. We haven't thought about the entire ecosystem, but it doesn't necessarily have to be a different world." Unquote. This is some really fun food for thought. Alien life might thrive on hydrogen-rich terrestrial exoplanets, and due to the nature of hydrogen atmospheres, these exoplanets tend to be among the easiest to see. Every week, it seems like the search for alien life is getting more exciting.